example, we are going to compare two groups, two independent groups. We are comparing two independent groups. These groups were the acetic acid concentration that was determined using a glass electrode, also known as a pH-meter, and a laboratory-made detector, a laboratory-made electrode. We are going to compare two independent groups that I can say the standard method and the proposed method. Well, the first thing to do is the first thing that I must do is load my data set. I will import my data set from Microsoft Excel file. Do not check this row since my samples don't have names. I already have your data loaded. I will overwrite this. I will click in spreadsheet 3. All spreadsheets that I use in this playlist were provided in the video description. I'm going to open it and I will edit my data sets. I can see my data set in here. I have my standard method and my proposed method. Before I do any statistical tests, I can compare these independent variables using graphs. I can use a box plots. I use selecting here to commander show me two box plots. I want to see a box plot for my standard method and a box plot for my proposed method. I'm going to here and I can see my box plots. The first thing that I see is using the standard method. I have the outlier result. When I use a parametric test, for example, in almost all books of analytical chemistry, you have a section about hypothesis tests, where when you compare two groups, when you are going to use parametric tests, every student that finish her graduation course, when he sees two independent groups, the first thing that he thinks in use to compare these two groups is the t-test. T-test is a parametric test that needs normally distributed data set, and you cannot have outlier samples. You could have non-equivalence variances. If the variances were different, you can do a correction. You can use the t-test Welch test. In the Microsoft Excel, you have the t-test presuming non-equivalent variances. Well, looking into the box plots, you already know that the variances of the two methods were different. You can compare methods precision using the interquartile range, the standard deviation, the confidence intervals, that is standard deviations. That is a version of standard deviation, but you are going to use the t critical value and divided by the square root of the number of observations. Whatever you can compare methods precision, use standard deviation, interquartile range, and so on. So the first thing that I have to do before I do anything else is delete these outlier results. So in spreadsheet 3A, this outlier result was deleted. So I am going to work again with this data set, but with my outlier result deleted. So I'm going to Commander. I will close this window, and in the Commander, I go to Data, import data from Microsoft Excel file. I go to OK, and I am going to open this spreadsheet 3A. The data is in here. Maybe commander will not like things like that when I have the name of my quantitative variable, but I have some points in here. So I will delete this point because its code led to some mistakes in the program later. I go to OK. I will continue my comparisons. I will do a box plots. I will select by groups. I will click on apply, and then now I have my box plots. Once again, I can see that the standard method has a lower interquartile range than the proposed method. I can see that the standard method is more precise than the proposed method. I can do also a plot of the means. I go to graphics. I will go to plot of means. I can select confidence intervals or standard deviations. Normally, methods precision were compared using standard deviations. I will go to apply, and I have my plot of means. I can see that the proposed method provides a higher average values than the standard method. However, the proposed method has a much larger standard deviation than the standard method. The proposed method has a much larger standard deviations than the standard method. So I cannot say that these two mean values are different because of these large standard deviations. So looking to the plot of means, I already know that both means were equivalent. I can see that the standard method and the proposed method provide equivalent results. I can see that the proposed method is less precise than the standard method. Due to this large standard deviation presented by the proposed method, I cannot say that is any significant difference between these two means. Well, now I can do my hypothesis tests. When I do my hypothesis test, the first thing that I must do is check for normality. Almost all books of analytical chemistry show how to compare two means. Any student that just finished had undergraduate school, every time that he see that we have to compare two groups, the first thing that he thinks is I will use the t-test. But remember, t-test is a parametric test. When you use a parametric test, you have to be normally distributed data. We use the Shapiro-Wilk test. The results of the Shapiro-Wilk test were presented in Studio Mainframe. And you can see that my data was not normally distributed. Since my data set was not normally distributed, might be not fair to use a parametric test, whatever. So I can go to Commander. I can use a parametric test. I will compare means. I will use an independent sample t-test. In this case, the standard method and the proposed method were independent. I will check right in here. I have my options. I want a two-side t-test, and then we're going to just a little detail I have to check in here. Assume equal variance or not. Let's see if the variances are equivalent. I go to statistics, variances. I use the F test. Since I have just two samples, I can compare the variances of two samples using a F-test. I will compare the variances, apply. Let me go into Studio mainframe. Looking to the results of the F-test, I can see that the variances were not equivalent. Well, using box plots and the plot of means, I already know that the variances were not equivalent. And I already know that method precisions were not equivalent. And the F-test show me what I already know from the box plots and the plot of means. So, once again, I will try a parametric tests. I know that my data was not normally distributed, so I should not use a parametric test. But you are going to do it just to show you how it works. In options, I will select no. I already know that my variances were not equivalent. I will go to apply. And I will see in here, since my variances were not equivalent, I can use a t-test presuming non-equivalent variances that is already known as the Welsh two-sample t-test. Well, using a parametric test presuming non-equivalent variances, it shows to me that my two means were equivalent. I already know this using box plots and the plot of means. The t-test, the t-test shows to me what I already know looking to the box plots and the plot of means. Well, anyway, I can do it also using a non-parametric test. So I go into Commander, I go to Statistics, non-parametric tests, and I will use the two samples Wilcox test that is it is also known as the Mann-Whitney test. I will do my non-parametric test. I am looking for a two-side test. I will let in here as default, and let me go into OK. My results will be showing here. And my Wilson-Hank-Sun tests, non-parametric tests were also known as a ranked tests, shown to me that the two means were equivalent. Well, this is in this case, students, you learned how to identify outlier samples. Never run any test before to delete your outlier samples. Outlier observations might greatly affect parametric and non-parametric tests. So the first thing to do before to compare two or more groups is delete outlier samples. Once that outlier samples were deleted, you might compare data sets. You might compare the two groups. In this case, you compared just two groups. You can compare these two groups using graphics. The box plots and the plot of means can show you if the two groups are equivalent or non-equivalent. Once again, I am showing here. You can show the standard errors as a standard deviation. In truth, you have the error bars. You can show it as standard deviations or confidence intervals. I also do it again. And the plot of means will show to you what we discovered later, what we confirmed later using the parametric t-test and the non-parametric Wilson test. The means were different. The proposed method provided larger concentrations than the standard method, but I cannot say that these two methods were different due to this large standard deviation of the proposed method. So we have more examples in this playlist, comparing more than 2 means. I expect that you enjoy, and please see the another videos of this playlist.